Hello, welcome to Brains Tutor. Our topic for today is analyzing the forces on a rough table and inclined plane. The first one we'll be treating is on a rough table. So the weight of an object is always acting downward. And then it will have a reaction. The reaction is always acting normal to the plane of reaction. And if I apply a moving force Fm to move this block, the original force I apply is called the moving force, which is denoted here by Fm. This moving force is going to be altered, or is going to be resisted by a frictional force. Now the frictional force is equals to mu r. The mu is called the coefficient of friction and is equals to the frictional force over the reaction. So if I make frictional force the subject of formula, I get mu r. So that is why we have what we have here. Now, a moving force is applied to this block. It is being opposed by a frictional force. Therefore, the real force that is going to move this block is called the force of acceleration, which is the net force after subtracting the frictional force from this moving force. So we can say the moving force is being opposed by the frictional force. So we are resolving horizontally now. So the moving force is being opposed by the frictional force. So which gives us the net force that is actually moving this block, called the force of acceleration. Let me define my terms, where Fm is denoted as the moving force, that is the original force that is applied to this block. Then Fr is the frictional force that is opposing the motion. Then we have the Fa. Fa is the net accelerating force. That is the net force that is moving this block after it's been subtracted from the frictional force. So if I want to find the moving force can now be equals to the Fa plus Fr. If I refer to this equation, if I refer to equation 1, I have Fm, that is the moving force, equals to the force of acceleration plus the frictional force. Now, the force of acceleration is usually given by mass times the acceleration, which is denoted by Fa equals mg. Likewise, Fr is equals to the coefficient of frictional force times the reaction. Now, if we now resolve, so the second one is that we are going to resolve resolving vertically. Resolving vertically, we can see R must be equals to the weight, and the weight is usually equals to the mass times acceleration due to gravity. Now, if that is so, I can substitute this value of R into this equation. Let me call this equation 2. So I can substitute the value of R. Now I know that my R equals mg. So I can say my frictional force is equals to mu mg. So if I put this value into, okay, let me call this one equation, well, let's call it equation 3. If I put this value of Fr into equation 3, I have that my moving force equals Fa which is equals to mass times acceleration. Okay, there is an error here. This should be Ma. So I have Fa, which is ma plus fr, which is equals to mu mg. So if I factorize m, I have m is common, so I have a plus mu g. So this is a simple way to analyze the forces on a rough table. What if this was a smooth table? What will it become? If this was a smooth table, or smooth surface. If this was a smooth table or smooth surface, what will happen? It means the moving force, that is the original force that was applied to this block, is not opposed by anything, which implies that Fm is equals to the Fa. That is, the force that was applied to move the block is equals to the force that is pushing the block. That it means there is no frictional force on a smooth table or on a smooth surface, which might cause the object to just be sliding anyhow.